Hello everyone, welcome to today's session. Today we are going to discuss how to perform a simple binary classification using different machine learning models. So we all know what is binary classification, just classifying a tuple into a class 0 or 1. So it will have only two classes. If you have multiple classes, then that is called as multi classification. So for this session, I have taken a data set. The dataset is banking dataset, which is available in Kaggle. So today I'm going to select some basic machine learning algorithm and I'm going to apply these algorithm on the banking dataset. So we are going to use logistic regression, support vector machine, Navy Bayesier, nearest neighbor, decision tree, and neural network. Come, let's directly go to the coding session. So this is the data set. The data set is available in comma separated format, in CSV format. So I'm just reading the CSV format into the data frame, pandas data frame. Okay, and here you can see the number of rows. Number of rows are around 11,162 and the number of columns are 17 columns. And here you can see the first few rows of the data set. So these are the columns we have in our data set. We have age column, job column, marital, education, default, balance. Okay, so these are the columns. So there are 17 columns in which the last column is a class column or the target column. So here you have only two values, either yes or no. So this data set is about to bank. So this data set specifies whether the customer subscribe for a deposit, term deposit, or they don't subscribe for a term deposit. So there's only two class, yes and no class. And these are the other independent variables. Okay, so these are the other features. You can call it as features or you can call it as independent variable. And the last one is your target. It is also called as dependent variable. Okay, so our job is to create a model which can classify a new features. If you give the features, if you give X, it should be able to find out what is Y. So this is the target. Okay, now if you see this data set contains categorical attributes. Okay, so it means there are string and some are categorical, some are nominal, some are ordinal in the sense it has some order. So here you have secondary, tertiary. Okay, so it means there is an order. Okay, so we all know machine learning algorithm cannot deal with strings. It has to be converted into numbers. Okay, so we have to do some pre-processing before we start applying the models. So the first step I'm done here is I'm trying to find out if there is any null value available in any of these columns. So I have to use a function is null, okay, and calculate how many null values are there in each column. So fortunately this data set doesn't have any null values. So here you can see the null values are 0 for all the columns. So we no need to replace a null value with any of the values. So suppose if you have a null value, you will replace it with 0, or you will find as average, or you will replace it with some special value. So no need to do all those things in this data set because it doesn't have any null value. Okay, the next thing I'm going to do is I'm going to convert all these categorical values into a numerical value. So for that I'm going to use LabelEncoder. There are different techniques available to convert into a numerical value. I am using a LabelEncoder. Means, for example, for marital status you have different values like married, single, divorced, widow. Okay, for each one will be given a unique value. So single will be given 0, married will be given 1. Okay, so you will be assigning unique value for each one. So we are using LabelEncoder. So I am passing what are all the columns I want to convert into numerical. Okay, so these are all the columns which has categorical data. So I pass all these columns as input. And finally, I will apply LabelEncoder and call fit transform. So when I call fit transform, you can see the result of the data set. Now here you can see all your categorical values are converted into numerical values. Okay, numerical values including the target value. Okay, target column. The next thing that I'm going to do is I'm going to plot my data set to check how many tuples I have in class 0 and how many tuples I have in class 1. So class 0 and class 1, there are two classes, S and no. Okay, so I'm going to plot it. So for that I'll be using a Seaborn package. Okay, Seaborn package. So I'm taking the last column, the deposit column. Okay, I'm going to take the unique values from the deposit column. There are only two unique values, 0 and 1. 0 is yes and 1 is no. And I'm going to count how many tuples are there, okay, for each of this value. So here I have to give a return underscore count is equal to true. So it counts and give me the unique value and the count. Okay, so I'm going to print it. So here you can see 0, how many instances are, how many samples are there in class 0 and how many samples are there in class 1. Okay, just I'm going to plot it using the SNS bar plot. Okay, so this is a bar plot. So this shows how many samples are there in class 0 and how many samples are there in class 1. So why we actually have to plot this is to find out whether you are having a balanced data set or unbalanced data set. Okay, this is not much a problem in this data set. It's okay. So exactly balanced data set you will not get, but this is okay. But some data sets will have very unbalanced number of records. So we have to plot this to check about your data set. After that, we will go ahead and divide that into X and Y. So X will be all the features, okay, before the last column, and Y will be your target column. Okay, so X is your input feature and Y is the target. Okay, all the columns, I'm going to consider all the columns to create a model. Okay, sometimes if you want to drop some columns which are not important, that also you can do. You can drop some columns, okay, which is not important to create a model, or you can use all the columns. Okay, so here I'm going to take X. X is all the columns before the last column, and Y will be your target column. Only one column, that is your target column. Now I'm going to divide the entire data set into training and testing. Okay, for that I have to call the method train underscore test underscore split and pass the value of X and Y, and we have to specify the size of the training data set. The size of the training data set is 20%. Okay, so now you will have your training set in X train and its target will be Y train, and for testing purpose we will use X valve and Y valve. So X valve will be your input and Y valve will be your target. Okay, so you have an X and Y. X is the input and Y is what you want to predict. Okay, so this will be the input, X train will be the input, Y train will be the output. So for training you give both the values to create a model. For testing you will give X valve and you will predict what is the output and compare it with Y valve. Okay, whether the model is correctly predicting or not. Okay, now we are going to create some models in machine learning. So I'm importing all these models like logistic regression, decision tree classifier, gradient posing classifier. Okay, what are all the models I want? I'm just importing all these models from sklearn library. Okay, so now I'll create a list because I'm going to create more than one models. Okay, so let me create all the models one by one. So the first model is given the name logistic regression, so I create the model. Second model is linear SVC. Then we are going to create decision tree. So just I'm calling the method name to create the model, and the model is created and it's stored in an array. Okay, so likewise a Gaussian NB, K nearest neighbor classifier, XG boost classifier. So we are creating 3, 4, 5, 6, 7 models here. Okay, and then I'm going to store all these accuracies, prediction score and recall scores of all these models. Okay, so we are going to create a all these models, and it is stored as a dictionary. So for each key in models.keys, okay, what is this model.keys? Actually, this model is a dictionary. Okay, so you're going to store all these models in a dictionary. Okay, so key will be the name of the model. Okay, so for all the name of the model, we are going to call the fit function on X train and Y train. So you're going to train your model. So after you train your model, you're going to test your model. Okay, to test your model, you call predict. Okay, on X valve. Okay, this will give you a prediction. Now you have to compare this prediction with the exact value, that is y value, okay, to calculate the accuracy. So you're going to compare what prediction the model is making. You're going to compare what prediction the model is making with the actual y value, okay, to find out whether it is correct or wrong. Okay, so that will be your accuracy score. Okay, so you're going to store the value of accuracy, store the value of precision, store the value of recall. Okay, all are dictionary, all are dictionary. So dictionary means, I think you know, it will have a key value pair. So key will be the model name and value will be what value you got for accuracy, what value you got for precision, what value you got for recall. So more than 7 models we are training. So for all the 7 models, it will be stored like this. I think you can see here a dictionary. You can see the dictionary here. Yes, you can see the dictionary here. The model name, colon, the accuracy of the model. Model name, colon, the accuracy of the model. So it will be stored in a dictionary. The name of the dictionary is accuracy. Similarly, you have a dictionary called as precision. So precision also contains key value. It contains the name of the model and the value. Okay, recall value. Again, precision, recall, accuracy, everything are stored. Okay. Now we are going to plot the ROC underscore AUC score curve. Okay, we are going to plot the curve. So we are calling the function, this function. This function will be available in this library. The library will be loaded here. So here you can see it is available in metrics, sklearn.metrics. You have to import this function and then you have to use this function to draw the graph. Then you have to print the classification report. Okay. Then we have to print the confusion matrix. So you can see all this are inside this for loop. Okay, so for all the models, you're going to calculate the accuracy, you're going to calculate the precision, you're going to calculate the recall, and then you're going to print the classification report. Then you're going to print the graph, ROC graph, and then you're going to print the confusion matrix. Okay, so here you can see the confusion matrix is written. So all these things are written inside the for loop. Okay, so you can reuse it. So you have to write this code only once and then call for all the models. So this for loop will repeat 7 times for each model. Okay, and then you can see the result here. So this is a classification report for logistic regression. Okay, and here is a curve, and here is a classification report for support vector mission. Okay, the confusion matrix, decision tree, again confusion matrix, classification report. Say for all the models, you can see the metrics here. Finally, you can print the accuracy, precision and recall of all the models. Okay, so here you can see you can put the accuracy, precision, recall inside a data frame and you can print the data frame. So it will be looking like a table. So here you can see the name of the model and accuracy, precision and recall. Okay, so you can create a data frame and put all these values. So here you find out that XGBoost gives you the maximum accuracy. The precision is also maximum for XGBoost and recall is also maximum for the XGBoost. Okay, so you can finally plot all these parameters into one graph. Okay, so here this graph shows you clearly that XGBoost has the highest accuracy. Okay, the next highest accuracy will be random forest. Yes. So this is how you can run multiple machine learning models and then compare its accuracy, precision and recall and precision. Just by writing one for loop, you can run different models at the same time. Hope you understood this session. In the next session, I will be teaching you how to create an ensemble of machine learning model with all these models. Thank you for listening.